Welcome to the deep dive. Today, we're jumping into something pretty important. Personal data security on proof-of-work blockchains. Think Bitcoin's tech.
Right. And you, our listener, want the key info without getting bogged down, so let's get straight to it.
Okay, so these blockchains, they have built-in security, right? Cryptography,
Not all.
decentralization.
They're designed for data integrity. Things like cryptographic hashing and being spread out mean they're tough to tamper with. Once data's in, it's, well, pretty much immutable.
That immutability, that's where it starts getting tricky with data protection rules, like GDPR, the right to erasure, correcting mistakes.
Yeah, big clash there. And things like data minimization, only keeping what you need. That's tough on a permanent ledger.
So our mission today is figuring out if personal data can actually be handled securely and privately on these systems. We've looked at technical papers, privacy analyses, ethical debates, a real mix.
Let's start with the tech basics, maybe. Keep it quick.
Good idea. So proof-of-work blockchain, it's a distributed ledger, no single boss.
And cryptography, like SHA-256 hashing, gives data a unique sort of fingerprint. If the data changes even slightly, the fingerprint changes completely. That's key for integrity.
And the proof-of-work part, that's the miners, yeah.
Right. Miners compete to solve a really hard cryptographic puzzle. Basically finding a random number, a nonce, that makes the block's fingerprint meet a certain target.
And the winner gets to add the next block of transactions to the chain.
Exactly. The block includes the fingerprint or hash of the previous block, linking them together. That's the chain. And they get rewarded, which incentivizes securing the network.
Which makes it immutable, like you said. Changing an old block means redoing all that work, plus all the work for the blocks after it needs massive computing power.
Practically impossible for deep blocks. And public chains are transparent. Anyone can see the transactions, though addresses are pseudonyms, not real names.
Okay, crucial point though. How does personal data usually get handled? It's not typically stored directly on-chain, is it?
Generally, no, especially not sensitive stuff. Because of that immutability and privacy rules, like GDPR, usually it's off-chain storage with maybe just a reference, like a hash or a web link, stored in the blockchain.
But even that reference, if it can be linked back to a person, it could still be considered personal data, right? Even if it's hashed or encrypted.
That's the nuance, yeah. If you can re-identify someone from it, regulators might see it as personal data.
No.
So the blockchain security is one thing, but the data's privacy is another challenge.
Right, so the pseudonyms, the public addresses, aren't truly anonymous.
Not really. You can analyze transaction patterns like following the money flow, cluster addresses that might belong to the same person or entity. It's called transaction graph analysis.
And there are specific ways people try to uncover identities.
Oh, yeah. Things like dusting attacks. Sending tiny, tiny amounts of crypto to lots of addresses just to see where it moves to link them together.
Huh, sneak.
Or address poisoning, creating an address that look almost identical to one you've used before, hoping you'll accidentally send funds there. And the big one, linking off-chain data. Like when you sign up for an exchange, you provide ID, know your customer, KYC. That links your real identity to your addresses.
And the type of blockchain makes a difference too. Public versus private.
Definitely. Public, like Bitcoin.
Yeah.
Super decentralized, very transparent, but low privacy and hard to make GDPR compliant. Private chains, controlled access, better confidentiality within the group, easier compliance, but they're centralized. Proof of work is less common there.
And permissioned is kind of in between.
Sort of, like a consortium chain. Identities are usually known. You can set granular permissions. Again, POW isn't the typical choice.
So this brings us right back to that GDPR conflict. Immutability versus the right to erasure or rectification.
Yeah, it's a fundamental mismatch. Some argue destroying the encryption key is like erasure, but regulators are skeptical.
And figuring out who's the data controller or processor in a huge decentralized network, that's tough.
Very tough. Plus data minimization and purpose limitation. Storing data forever kind of goes against those principles. This really highlights why privacy by design, thinking about privacy up front, using off-chain methods, encryption is vital.
It's that classic trade-off again. Immutability gives you amazing integrity, this perfect audit trail.
But makes fixing errors or deleting data incredibly hard. You need really good quality control before data goes on-chain.
And transparency builds trust because anyone can verify, but it opens the door to de-anonymization. The transparency paradox.
The trust model relies on that math, the cryptography, the economic cost of attacking via POW, and the openness. But, it doesn't guarantee the input data was accurate or that bad actors aren't using the system.
So fundamentally, this tech challenges our usual ideas about privacy. Maybe we need privacy built in from the start, not bolted on.
That's the direction things like self-sovereign identity or S as are heading. Giving users control over their digital identity using blockchain for things like decentralized identifiers, DIDs, and verifiable credentials, you hold your own proof.
Sounds empowering, but also complex. Managing your own keys sounds risky if you lose them.
It is. There are challenges. Usability, key management, the need for standards. It shifts responsibility heavily onto the individual.
And ethically. Permanent storage. What about the right to be forgotten? Storing sensitive data forever feels unsettling. Who decides what gets locked in stone?
Big ethical questions. And that's before we even touch on the environmental impact of proof-of-work's energy consumption. That's a whole other major ethical debate.
Just briefly, any alternatives that help? We hear about proof of stake.
Yeah, POS is much more energy efficient. Validators are chosen based on the amount of crypto they stake or lock up. But importantly, it doesn't inherently change the privacy aspect at the ledger level if it's still a public, immutable record.
Okay, so looking forward, what's on the horizon for privacy?
There's a lot of work on privacy-enhancing technologies, PETs, things like zero-knowledge proofs. ZKPs are really interesting. They let you prove something is true without revealing the underlying data. Think confidential transactions or verifying identity attributes.
Still sounds pretty complex, though.
It is. And homomorphic encryption, doing calculations on encrypted data, is another potential avenue, but it's computationally heavy right now. And, of course, regulation like GDPR and others will continue to shape how this all evolves.
So applications in healthcare, finance, SSI seem possible, but only with really strong privacy measures baked in.
Absolutely. The core tension remains. POW offers fantastic integrity, but major privacy hurdles for personal data.
So the big takeaway seems clear. Directly storing sensitive personal info on public HowW blockchains is generally not a great idea from a privacy standpoint.
Pretty much. Careful design is crucial. Thinking about permission systems, definitely using off-chain storage for sensitive data, and exploring those PETs.
Which leaves us with a final thought for you, the listener. Given this permanence, this immutability, what kind of information do you actually think deserves to be recorded forever? And what safeguards are non-negotiable to protect individuals as these technologies become more common? Something to chew on. Thanks for joining our deep dive today.